This is your video for your notes on properties for SOL 6.19. It covers pages 113 through 116 in your notebook. You'll need a pencil and a highlighter to complete these notes. Please copy everything in your notebook that you see in this video. The property that states that the product means multiplication, of any number and 0 is going to be equal to 0. So when I multiply a number and 0, my answer should be 0. So product is what we're getting from the multiplication sign, and I have a number times 0, and that is 0. So this is an example when we're multiplying by 0 of the multiplicative property of 0. And multiplicative sounds a lot like the word multiplication. So when you have the multiplicative property of 0, you know that you are going to multiply something by 0. The property that states that the sum means addition, of any number and 0 is going to be equal to that original number. So if I add a number and 0, it's going to be that same number. So the sum is coming from that addition sign. So sum is going to be the answer to that addition problem. And if I have a number and 0 that I'm adding, the sum or the answer is going to be the original number. So 5 did not change at all. So we did not change its identity. So the identity of the number after adding 0 did not change. So this is going to help you remember the name of this property. And there's two different ways that we can name this property. We can name it the identity property of addition, because we're not changing the identity once we add something. And the other way to write this is to call it the additive identity property. So either way, you kind of have the word add in there and you have the word identity. You need both of those words to have the additive identity property. Now the property states that the product, or multiplication, of any number and 1 is going to be equal to that original number. So it doesn't matter what number, but I'm going to have the product, or we're going to be solving a multiplication problem. I'm going to have a number and 1, and that answer or product is going to be that original number. So when I multiplied by 1, I did not change the identity, so the identity of that 5 didn't change. So 5 is still 5, even after multiplying by 1. So there's two names for this one as well. We can have the identity property of multiplication because we're not changing the identity of our original number when we're multiplying in this situation. And the other way we can write this is we can call it the multiplicative identity property. So either one of those two names, you need to see that one of the words has something to do with multiplication and one of the words has something to do with identity and not changing that identity. The flipped fraction of a number. So when I'm flipping them around, so 8 is like 8 over 1. So if I flip it, the numerator becomes the denominator becomes the numerator, and the reciprocal, so the reciprocal of 8 is 1/8, and the reciprocal of 1/8 is 8, and we can kind of go around that cycle. So if I want the reciprocal of 1/8, I flip them and I get 8. And then if I want the reciprocal of 8, I flip them again and I get 1/8. So 8 and 1/8 are reciprocals of each other, or the flipped fraction version. The property that states that a number multiplied by its reciprocal will cancel out to equal 1. So I'm going to write 5 as 5 over 1 because that's how we write whole numbers. And we see 1 in the numerator. 1 is in the numerator for the first one, and 1 is in the denominator for the next one. And so we flip-flop the denominators and numerators. 1 times 5 in the numerator is 5, and 5 times 1 in the denominator is 5, and 5 divided by 5 is equal to 1. So we see that everything ends up canceling out when we multiply by the reciprocal or the flipped version. So we're kind of flipping it upside down, and when we're thinking about flipping things, another way to say flip in English is to invert. So when we're thinking about the flipping, we want to think about the inverse property with multiplication. And the number when added will not change the value or identity of another number. So 5 plus 0 gives me 5. The identity of 5 didn't change. What plus 0 equals, so 7 plus 0 equals 7. The identity of that 7 didn't change when I added 0. So if I don't change the identity when I add a 0, then 0 is the additive identity element. So that is the additive identity. The number that when multiplied that will not change the value or identity of another number is going to be 1. So 5 times 1 is 5. I did not change the identity of that 5 when I multiplied by 1. And 7 times 1 is 7. I did not change the identity of that 7 when I multiplied by 1. So when I'm multiplying and I don't change the identity, then the number 1 is called the multiplicative identity element, or the multiplicative identity. A little reminder is that when you have a whole number and you want to write the whole number as a fraction, you write it over 1. And a whole number over 1 is going to be equal back to that whole number. So 4 equals 4 over 1. So if I wanted the reciprocal or the inverse, I am going to flip it. So 4 over 1 and 1/4 are multiplicative inverses of each other. If I already have a fraction, 3/2, if I invert it, I can change it to 2/3. So 3 in the numerator became 3 in the denominator. 2 in the denominator became 2 in the numerator. And now we have our two inverses. So we have the numerators flip to denominators and denominators flipping to numerators. So if you want to remember how to take the reciprocal or to find the inverse of a number, the multiplicative inverse, then we're going to switch the numerator and the denominator. 5 times 0 is equal to 0. So this property is showing that I'm multiplying by 0. Then this is called the multiplicative property of 0. So the name of this one suggests that we're multiplying by 0. So every single time you multiply by 0, you're going to have this property. So times 0 kind of explain we're multiplying by 0. That's why we have the multiplicative property of 0. Now 3 plus something would give me 3. I need to figure out what that additive identity element is. When I add 0, it doesn't change the number or the identity of that number. So we just used the identity property, but we didn't change the identity when we were adding. So that is the identity property of addition. So every time you see where you're adding 0 and not changing the identity, that's going to be that's going to tell you to do that property. 6 times 1 is going to give me 6. So whenever I multiply by 1, you're showing that the number doesn't change. The identity of that number doesn't change. So we're going to have the identity property of multiplication. So we don't change the identity, but we don't change the identity through multiplication. So when we are multiplying by 1, that's when we're going to see the identity property of multiplication. Now 0 plus 4, we're adding 0. So when we add 0, we don't change the identity through that addition. So we're going to have the identity property of addition. So when we do add 0 to 4, we're not going to change the identity, and we get 4. Now 3 is the same thing as 3 over 1. And when I do 3 times 1, multiply across the numerators, I get 3. And 1 times 3, multiply across the denominators, and get 3. And 3/3 equals 1 whole. So we see that the 3's ended up canceling out to give me 1 whole. So when I flipped these fractions, or found the reciprocal and multiplied by its reciprocal, these ended up canceling out. So when you see the flipped fractions cancel out, we want the inverse property, and since we're multiplying, the inverse property of multiplication. Now you can tell if we're using the inverse property of multiplication if we are multiplying by a reciprocal, and when you multiply by a reciprocal, your answer is going to equal 1. If I have 3/7 and I want to multiply by something to equal 1, then I need to multiply it by the reciprocal. So if I want stuff to cancel out, I need to put the 7 in the denominator into the numerator, and the 3 from the numerator into the denominator. 3 times 7 is 21, and 7 times 3 is 21, and 21 divided by 21 is 1. So we see that everything ends up canceling out. So this is using the inverse property of multiplication. So we multiplied by the reciprocal, and when we multiplied by the reciprocal, we got an answer of 1. If I multiply a number by 0 to get an answer of 0, then I can really put any number in here. 0 times 7 is 0, 0 times 6 is 0, 0 times 242 is going to be 0. So whenever I am multiplying by 0, we're going to have the multiplicative property of 0. So if I multiply by 0, then you know that this is the property that we're using. In the next example, we see 10 times 1. When I multiply by 1, it doesn't change the identity of that 10. So 10 times 1 is equal to 10. So I didn't change the identity, and I'm using multiplication. So this is going to be the identity property of multiplication. And you can tell if this is the property being used when you see that we are multiplying something by something that doesn't change the identity, or multiplying by 1, because that doesn't actually change anything. Doesn't matter what numbers you have, but if I have a fraction and I multiply by another fraction to get 1, then I need to flip it. So the denominator becomes the numerator becomes the denominator, and triangle times square, the squares on the top and bottom will cancel out, the triangles on the top and bottom will cancel out, and that would equal 1. So we inverted the fractions, or flipped the fractions, or multiplied by its reciprocal to cancel out, and we used the inverse property of multiplication. So whenever you see that you're multiplying by the reciprocal and it cancels out to equal 1, then we're using the inverse property of multiplication. I don't care what I'm adding 0 to, 0 doesn't change anything. So if I have smiley face and I add 0 to it, I'm going to still have smiley face. So I did not change the identity of that smiley face emoji, and we're going to use the identity property of addition, because adding 0 doesn't change the identity of whatever we're adding 0 to. So whenever you're looking for the identity property of addition, you need to look for when you are adding 0. The additive So plus identity property means that we're not going to change the number. So if I add 0, I'm not going to change the identity of that number. So the additive identity property is shown in which of the following? So I'm looking at this and I see 4 plus 1 times 0 plus x minus 6 equals 4 plus 0 plus x minus 6. It looks like the x minus 6 didn't change, but inside here, I want to kind of highlight what changed. 1 times 0 became 0. So that's what's actually happening. So in this situation, what's happening is 1 times 0 equals 0 in that next step. So I'm multiplying by 0, and I want to add by 0 to show the additive identity. In this next example, I see that this x came from this x plus 0. So let's rewrite what actually changed. So in the first example, we had x plus 0, and in the second example, it was replaced with x. So x plus 0 equals x. We were adding 0. And we didn't change the identity of x. So far, B looks like a good answer. In C, 5 minus 2 turned into 3. So in C, what's happening is that we're showing that 5 take away 2 is equal to 3. Well, all those identities changed, and C is definitely not the correct answer. In this example, we have 4 plus 6 minus x plus 2 times 4 equals 6. And we see that the 2 times 4 becomes 8 in that next example. So we have 2 times 4 is 8, but all those identities changed, and that's not really showing us anything other than arithmetic. So B is the correct answer, because we're adding 0 and not changing the identity. Number 2, the multiplicative identity is the number that we multiply by to not change the actual number. So when I multiply by 1, it doesn't actually change anything. So it's asking which one of these choices is showing the multiplicative identity. So looking at A, we kind of look all the way through and see what's changing. And in the first half, we have 2 times 4 equals 8. So let's kind of rewrite that. So we have 2 times 4 on the left, and we see that that's replaced with 8 on the right. That's multiplying, but all of those numbers actually changed. So just because it's multiplication doesn't mean that we're showing that property. In answer choice B, we have 5 minus 2 is 3. So 5 minus 2 is 3. We're showing subtraction. So if it's not even the correct operation for multiplication, then B is not correct. In answer choice C, we see that 1 times 5 changes into 5. So we see that we're doing 1 times 5 equals 5. And the identity of 5 didn't change when I multiplied by 1. So far, C is looking like it's the multiplicative identity property being illustrated. And here we change x plus 0 into just x. So x plus 0 equals x. Now, I didn't change the identities of x. X stayed the same, but I'm adding. So I want answer choice C because that's the one that's showing the identity not changing, but with multiplication. Which property is shown in the following number sentence? So if I have 1/9 over at times 9 over 1, we can kind of flip that and find the reciprocal. So if I take 1 and 9 and flip them to the other side of the fraction, I get 9 over 1. And if I'm multiplying, A includes multiplication, B and C do not, and D includes multiplication. So we can kind of get rid of the ones that don't even have the correct operation being shown. So multiplicative identity. When we have the identity, we have a number. The number doesn't change. So 1/9 and 9 over 1 actually do change. And the inverse, when I invert something, it's like I flip something. Or, so the inverse is to invert it or flip it. So 1/9 flipped is the same as 9 over 1. So it looks like A is the correct answer. So when I multiply 1/9 times 9 over 1, I get 1 times 9 is 9, 9 times 1 is 9, and 9/9 equals 1 whole. So we wanted it to cancel out to equal 1. Tess is demonstrating the identity property for addition in the real number equation below. So if I'm doing the identity property for addition, I'm adding 0 because 0 doesn't change the identity. So if I add 0 to something, then that something doesn't change. So 2x, the identity of that expression, does not change. So the answer A is the correct answer. Which of the following is equivalent or equal to the expression below? So I want to know what's equal to that. Now I'm going to use some of my properties. Right here, I notice that when I have parentheses next to each other, that I'm actually multiplying. So I'm going to kind of rewrite that. 6b times 0 plus 9. So when I see that I'm multiplying by 0, I'm going to cancel that out. So 6b times 0 is going to be equal to 0 because the multiplicative property of 0 says that. And right now I see that D is shown in my answer. What I would notice next if I needed to keep going is that I could add 0 as well. And anything plus 0 is equal to that same number. So b plus 9 would be the simplest form for that expression. But answer choice D is still an equivalent expression. Identify each number sentence that uses the multiplicative property of 0. So we are going to be multiplying by 0. And when I multiply by 0, my answer should be 0. So let's see what's actually going on in these sentences. Here I have 4 plus 0 minus 3 equals 4 minus 3. So the 4 plus 0 became 4, and the minus 3 is still on both sides. So here we were adding 0. That is not an example of when we multiply by 0. So this is not a correct choice. 2 plus 0 times 6, well, we see the 0 times 6 kind of became that 0 on the other side. So here we're multiplying by 0. This is the multiplicative property of 0. When you're multiplying by something by 0, your answer is 0. Here we see 6 times 0 equals 0. So we're multiplying by 0 again to get 0. And this is another example of the multiplicative property of 0. 7 plus 0 is 7. So here we're adding 0, and this is not a multiplicative property of 0 being shown, because it's addition. Here we're subtracting, and we see that 3 minus 0 is equal to 3. So subtraction isn't the correct operation for the multiplicative property of 0. Identify each number sentence that uses the inverse property for multiplication. So when I'm looking at the inverse property for multiplication, I want to think about the reciprocal. So when we have the inverse, we need to use our flipping of our fractions. So this is when we see fractions, but we also need to think of our flipping as multiplying by the reciprocal. So if we multiply by the reciprocal and they both cancel out to equal 1, then we're going to have the final answer. In this first sentence, we have 1/3 times 6 plus 7 equals 2 plus 7. So here we're showing that 1/3 times 6 equals 2. So we need to look at this. And 1/3 times 6 over 1, so 1/3 times its reciprocal would be 3 over 1. So we multiply by 6. And 1/3 times 6 is equal to 2, but we want to multiply by the reciprocal. And the reciprocal or flipped version of 1/3 is 3 over 1. In this next example, we see that 1/3 is being multiplied by 3, and our answer is 1. So we want to check that 1/3, and we flip it to give us 3 over 1, and that equals 1. And that's the situation that's being shown here. In this next example, we see that 1/2 plus 1/2 turns into an answer of 1. So we're not even using multiplication here. We're using addition. So with addition, that's not going to be the inverse property for multiplication. We see that 2 times 1/2 becomes 1 in this next example. And 2 is the same thing as 2 over 1 times 1 over 2. And 2 times 1/2 is equal to 1. So we are multiplying by the reciprocal to get 1 whole. This next example, we see 1/6 times 6 is going to equal 1. And 1/6 times 6 over 1 gives you 1 whole, because 6 divided by 6 is equal to 1. When I multiply that by the reciprocal, it will give me 1. Identify each number sentence that uses the inverse property for multiplication. So let's identify what's going on in each step of the number sentence. So when we're doing the inverse property for multiplication, we need to remember that we're multiplying by the reciprocal, and we should equal 1. So the reciprocal is when you're flipping the fraction or inverting the fraction. So here we see that 1/2 plus 1/2 is replaced with by 1 on the other side of the equation. So here we're using addition. We see that 1/2 plus 1/2 is replaced by 1 again. In this example, we see that 1/5 times 10 is replaced with an answer of 2. We see that 1/6 times 6 is replaced with an answer of 1. And 1/5 times 5 is replaced with an answer of 1. So that's what's happening in each situation. This first situation, we have addition. So that is not showing the inverse property for multiplication. So both of these are actually showing addition. And if it's the inverse property of multiplication, then we're not going to use addition. So when we have 1/5 times 10, that gives us 2. And we want the reciprocals to equal 1. And those aren't reciprocals of each other. 1/5 times 5 over 1 would give us 1. And here we have 1/6 times 6, which is also written as 6 over 1, and we get that that cancels out to equal 1. So we multiply by the reciprocals, or the flipped version, and they canceled out to equal 1. This does show the inverse property for multiplication. We'll see that this next example equals 1 as well, and then the 5's flip and the 1's flip. So we flipped both fractions, or both numbers, and when multiplied together, we got 1. This next one is asking us which property is showing the following number sentence. So here, 5's are flipped, and the 2's are flipped, and we're multiplying. So we multiplied by the reciprocal, and when we multiplied by the reciprocal, that equaled 1. So it's not the additive identity because we're multiplying. The associative property has to do with associating different numbers together or grouping different numbers using parentheses. Identity property means that the number doesn't change. So when we multiplied this, both numbers actually changed. All the numbers changed. So the identity property is not going to work. And associative has to do with parentheses and grouping items. So C is not being shown here either. The inverse is when we are inverting or flipping the fractions or multiplying by the reciprocal. So we are showing the multiplicative inverse property. Which property is illustrated by this number sentence? 13 times 1 equals 13. So when I multiply by 1 and the number doesn't change, I didn't change the identity. So first off, we are using multiplication. And second off, the identity of the number didn't change. So when it's not changing, we need to think about the identity property. So it didn't change identities when I multiplied. So Associative property of multiplication, multiplicative property, multiplication, multiplication, multiplication. Distributive property, that's when we multiply some things, but add other things. So we're not using the distributive property. So all of these remainder ones have multiplication having to do with it, but the one that we're going to look at is the one that has the multiplicative identity. Associative has to do with grouping and with parentheses. Commutative has to do with moving or commuting things. So we are moving or switching places when we're commuting. And that's not what's actually happening here. The most important thing is that we're multiplying by 1 and not changing the identity. Inverse is when we flip things, and it doesn't look like we really flipped anything in this example. And the multiplicative property of 0 is when I multiply by 0. I'm not multiplying by 0, I'm multiplying by 1. So we are going to get rid of the multiplicative property of 0, and this answer is the multiplicative identity property. You should have everything in this video copied in your notebook. If you have any questions, write them down and ask your teacher.